Good afternoon, everybody. I hope that you can hear me. I think we can start for this first session. This will be an on tutorial session, having the main goal to support you in the use of a Copernicus app for the evaluation of the heat stress and related indicators. Each end-on tutorial will have a duration of 30 minutes, I've told before. In the chat, you can find the link to the Copernicus to the Copernicus website, and then you can start to use the app that today I will describe. I want to also remark that this app is not provided, is not implemented by CMCC or by the other institution working in this specific project, but by Vito Research Institute and other colleagues. If you want to have additional information on this, you can go on the web page, and here I think that you can may see my my laptop. You can see that here there are all the contact and information that can be useful for additional information. Today will support me also my colleague at CMCC, Angela Rizzo and Francesco Repola. Okay, I forgot to say that I am Paola Mercogliano and I work at the CMCC Foundation, and in particular I lead the REMI division working on the use of regional climate model and geological impact. Okay, if you have some remark, or if you want, I don't know, in order to avoid to have a problem with the connection, you are unmuted. You are muted, but if you want, you can write in the chat. Okay, we can start with the general introduction of the problem. As you already know, there is an increasing of the global temperature that is already ongoing, and this is expected to affect the frequency and intensity of the heat extreme. Of course, this issue has a very strong impact on human health, ecosystem, and the socioeconomic sectors. The evaluation then of the expected frequency and severity of temperature extreme is something very fundamental for the climate adaptation challenge, and many studies are ongoing on this item. There are a different definition of heat wave. That is an indicator used for the evaluation of the heat stress. The heat wave is a prolonged period of extremely high temperature for a particular area. As told before, there are many, but perhaps the more famous, the more used in the climatological community is the one defined by the ETCCDI reported in this slide. And heat wave can be defined as the occurrence of at least 6 sequential days with maximum daily temperature above the corresponding daily threshold value of the 90th percentile. Okay. There are many different climate data that can be used for the evaluation of these indicators in the historical period and in the future period. We have regional, we have the global circulation model and the regional climate model. In the Copernicus platform, the tool that we are going to show you today is used the regional climate model. These kind of model are usually used when you are interested to look at the impact of climate change and to the characteristic of climate change at the local level. This is due to the higher resolution of regional climate model with respect to the global climate model. As reported in this picture, the regional climate model only evaluates the climate change in the limited area. In the case of the application that we are going to study today, the area interested is the European area, and the data used as reference are the Eurocordex data. The Eurocordex data are developed in the framework of the Eurocordex program. The in general, the Cordex program has the goal to develop study with the regional climate model, then develops studies using this kind of dynamical downscaling. There are also other areas that are considered, of course, in the Cordex program, but today the focus will be over the European area. Okay, now I will start to describe this tool, and we're having the goal to identify the area exposed to the heat wave event, and we will use the data provided by Copernicus Climate Change Service. And in particular, today we will look at the evaluation of the number of heat wave days for European countries derived from climate projection. My suggestion is to go to this link and then to try to look at different picture at what is reported on this link. Okay. Okay. First of all, as told before, the Copernicus application named climate projection of a number of heat wave days for European countries, and specifically is devoted to the calculation of the number of heat wave days experienced in Europe on the historical period 1976-2005, but also are considered the projection on the two different future periods of 30 years. 2031, 2060, and the long time range at the end of the century, 2071, 2100. Two different IPCC concentration scenarios are considered, the RCP 4.5 and the RCP 8.5. The RCP, the 8.5, is also named the business as usual. Then is not expected to have mitigation strategies, and then the temperature, the global temperature, generally speaking, increase very high, while the RCP 4.5, we have the application of some adaptation, some mitigation strategies, and generally the pathway between RCP 4.5 and RCP 8.5 try to be different during the 2050 years. Okay, there are, if you now look, I don't know if you are able to okay, if you click on the website that I told you before, you now are here in this picture. Okay. Okay, here you can find three different definitions for the heat wave. The first one is the definition adopted by the paper of Jacob et al. In 2014, and in this paper was evaluated this indicator for heat wave using the Eurocordex data at the highest resolution available, about 12 kilometers. And specifically, the definition used, if you select if you select this kind of definition in the drop menu, if you select the definition, the climatology Eurocordex, you will evaluate the heat wave using this specific definition. Specifically, heat wave is represented as a period of at least 3 consecutive days on which the daily maximum temperature exceeds the 99th percentile percentile of the daily maximum temperature of the period from May to September months over the control period. There is also the possibility to evaluate the heat wave intensity using another definition, the Hero 8 project definition. This is another indicator, and in which is considered another important variable, the apparent temperature. And the apparent temperature is a measure of the discomfort, heat, and it also considers the humidity. And this is developed on the basis of physiological studies on evaporative skin cooling. If you are interested to have more detail on this definition, you can look at the documentation available on the Copernicus app. Also, there is the last possibility to look at other definitions defined at national level. We have different 8 member states that provide their own the definition. Mainly, for example, in the case of Italy, the definition, the indicator is the same for all the Italian area, but is changed the threshold used depending from the area that you have selected. Okay. After that, you have selected in the drop menu the kind of indicator that you want to use to evaluate the heat wave. Then you can decide the area where you want to calculate this indicator. There are the opportunity to have evaluation at the national level from many countries. Belgium, Italy, Hungary, Lithuania, and so on. But there is also the opportunity for 4 different countries, Belgium, Hungary, Italy, and Lithuania, to have information using on a more resoluted area. Not only NUTS 1, but also NUTS 2 level. Then you can have a zoom. You have to take care because in order to look at a special area, you have to use the zoom button. You cannot you cannot select the area from the drop menu, but you have to use the zoom button. Also in this case, please consider the specific manual available, and in particular the page from 5 to 8 for the national definition that I explained you before need to be carefully checked. Okay, now we can start to give more detail on the script. Okay, the dataset provided by this public is a hot and cold spell for Europe derived from climate projection. In particular, today we consider the dataset, the subset concerning the hot spell. It is also important to consider that the input variables of this tool is a bias-adjusted 2-meter air temperature, evaluated in Kelvin temperature, in Kelvin degree, and 2-meter dew point temperature. This is very, very important because thanks to the application of the bias correction, the output of this tool are the absolute value on the period that on the future period that you have selected, or on the historical period, because without using the bias correction you can only have the anomaly. But thanks to the application of this additional tool, you can have the expected absolute value over the area and the period of interest. As told before, you can select the kind of indicator that you want to use for the evaluation of heat wave. Then you can select from the drop menu the period, the scenario, and then using the zoom button you can select the country and the NUTS level. And when you made all this selection, then you can have the output variables, that is the number of heat wave days. Okay, there are also on the same page some details on the input that can be very useful if you are interested to download this data and then to perform additional analysis. As told before, the data used for the evaluation of these indicators are the Eurocordex. Eurocordex at 0.1 degree of resolution. That is about 12 kilometers. This is the highest resolution for the Eurocordex data currently. What else? Here you have the area that is covered by using this data. This is the temporal coverage of the data set, and here are the temporal resolution. And here you have, for example, the name and the units of the variable. Okay. If you are interested to go in more detail on the script that is used in the app for the evaluation of these indicators, I can briefly explain the main step of the script that you can find on the web page. There are essentially 6 different steps in this tool. First of all, you provide to have the computation of daily temperature time series, then the computation of daily apparent temperature time series, computation on the heat wave days following the definition that you have selected. You perform then the climate average over 30 years, and then you evaluate the ensemble average, because perhaps I didn't mention it, that in the framework of the Cordex, Eurocordex, you have different model configuration for the same scenario. Then the result that you will see is obtained as the mean of these different model, selecting the scenario and the period. But you have also, and this is very important, the evaluation of the uncertainty related to the use of the ensemble mean. You have the standard deviation that is very important for the risk analysis. And then finally, you have in the script, there is the regridding on the regular latitude longitude grid in order to have the map. There are different opportunity for the output. You can download the figure in the .png format, while you can have the time series, while you can also download the NetGDF. NetGDF is a quite common format used in the climate application. It's not easy to use this kind of format, but for expert user can be very useful if they want to use this data for additional analysis. Okay, here there is an example of, for example, of selection. Here it has been selected the climatological Eurocordex in the definition of the heat wave. Here you have selected the near future period using the RCP L.5, and here you have the output, that is the evaluation, the number of heat wave days for European countries for the selected period. Okay, here is another selection, but I think that now you can start to make your test. And okay, and for example, if you select Italy, I decided to not do this in real time, because of course, if there are a lot of people asking for the same information, the system is quite slow, but this is you can do when you want, but this is an example. For example, if you select Italy, you have then on the historical period the number of the heat wave, and here you have a general map concerning the trend of the number of heat wave from the historical period being then 1976 up to 2085, using RCP for the .5 in green, and this is in light purple RCP 8.5. The medium line is the average of the different Eurocordex model, while the upper and the lower curve are the spread, the uncertainty. It is very important to have an idea of the algorithm used for the evaluation of the uncertainty, because there are different definitions for the uncertainty in the literature. In this case, this depends from the mean, from the standard deviation, and from the number of models that builds the ensemble. Okay, if you, here there are other examples. For example, not only the historical period, but also you can have the future period, and then using this button, you can go to the other period. And okay, the same. Okay, and okay, this is what I told you before. In this picture, you have the value. You can take a look of the value for the absolute value, for the mean, for the upper limit, for the lower limit, using the two different scenarios and considering the different period of interest. If you are interested to go in detail at the national level, if you use, for example, then you have to click in national definition. You have to use the zoom button here, plus, and then, for example, you can have a look to this specific area in Italy. If you select this area, you will find the same information that we had in the other areas, but at this time using a different definition for heat wave. And as I told you before, at the national level, in particular for Italy, the indicator is the same, but the threshold is different depending from the area. It is based on epidemiological studies performed at in this area. Okay, here more or less the same information. Yeah, if you select here, you will have here the far future, depending the number of heat wave days, average days per year over the period selected. And that's all. Okay, I think that now we have 5 minutes. If you want, you can try to use the app, and then if you have a question, my colleagues and I will try to reply. Thank you. Okay. I start to reply to your question. Someone say the dataset is available only over Europe. Yes, for the moment, yes, because as told you before, in principle, the data used is Eurocordex. And then there is a pre-processing of the input related to the use of the Eurocordex data. The script can be used, of course, we have to change a little bit, but can be used in general also for other areas. But what you need to have is the Eurocordex data available over other areas. for the moment, then it is only available over Europe. But in principle, Cordex, the Cordex program cover all the area of the world, but it is not implemented in this tool. About the possibility to have the same analysis for the country were not mentioned at the beginning. I will say that the script can be, of course, can be generally used, but this depends from the availability of the definition and threshold also in the other areas. Then I suppose that it's not possible for the moment, using this application, to go in to have, for example, NUTS3 in other European countries analysis because they are not evaluated currently. Okay, I have a question. Can we consider the rate definition and development of the heatwave definition on WMO WHO 2015? What is the period used for the calculate the threshold? Okay, I think that my suggestion is to look at, because in the documentation, in the page of the documentation that is available on the website, are reported all the threshold and definition and other general information. And as told you before, these thresholds are evaluated and also considered currently in the heat warning system that we have in Italy, and they have been evaluated in Italy from the Department of Epidemiology of the Regional Health Service. For the warming from the bulletin concerning the heat wave. Then the threshold are local, if local means regional. Yes, I received an email. Are the number of heat wave days in the future defined using the same threshold control period of the historic heat wave? Yes, this is in the definition. Yes. Perhaps I can. Yeah, in the same. I won't say that here is not specifically mentioned the control period, but I suppose usually that is evaluated on the control period. Also, if in this case you have to consider that the 99 percentile is concerned the maximum item evaluated for each month. I suppose yes, but you have to check because in the documentation this is not clearly reported. Usually, if you want to see at evolution of the indicators, you consider the percentile on the reference period as performed in the Eurocordex indicator. But I'm not sure for this. For the moment, I don't see any additional participant. And then, okay, I received a very good question saying that heat stress can be misleading because this is an evaluation of the heat wave. Completely, I agree. If you look at the first definition really concerns only climate indicators, and then is an evaluation of the heat wave. But if you look at the definition reported by the HeroHeat and the national definition, this indicator is more related to the heat stress because there are also variables like the maximum apparent temperature really concerning the stress of the heat wave. In fact, as I told you before, the definition, the threshold is defined by an epidemiological service, then is more related to the impact. But okay, we noted the same. The heat wave and heat stress is two different concepts. But of course, in this way, heat wave is correlated in some way to the heat stress, and as told you, there are different definitions, also depending from your output to your studies, and then you can decide to look only at the climate part or to define specific indicators, also taking into account the impact. It depends from your application. In this app, I think you can find either the solution, the HeroHeat project, more related to the impact and to the heat stress, but also the heat wave, more related to the climate condition. The suggestion could be also to download the data set, and then because it's possible to download the data set of the temperature of the indicator, and then to define your indicators more related to heat stress. Of course, if you download the NetCDF, if you are an expert user, you can use this data to go in deep detail and to define additional indicators, taking also into account more specifically the heat stress on the area, for the heat stress in general. I don't see any additional participant. And then if you want, you can continue to use the tool. And then if you have additional question. Okay, thank you. I think that now we can stop this session. We will have another one in 10-15 minutes, depending from for the people attending. And please don't hesitate to write us an email. But as I told you before, my suggestion, if you want to go in detail on this service, you have to refer to the Copernicus web page. Okay, thank you for your attention. Bye bye. Okay, Good afternoon, everybody. Now we can start with the second session of today concerning this end-on tutorial about the using of fast script to calculate the heat stress. I am Paola Mercogliano. I am I work at CMCC Foundation as a leader of the Regional Model and Hydrological Impact Division. And today with me there are also my colleague Angela Rizzo and Francesco Repola supporting me for this session. In order to avoid to have some disturb, you are unmuted. Then, if you have a question, please use the chat. Also use the chat to have the link to the Copernicus app on the heat stress that today I will describe to you. Okay, I want to also mention that it's expected that we have a 30-minute session, but the first session was a little bit longer. Then we will have another, now this session will be of about 40 minutes. If you use the link, you can start to use the script. Then if you have a question, you can to do it during my presentation. And I think that we can start. I hope that someone can see if you are listening me. Okay. Generally, okay. Oh, I didn't mention that this tool is not implemented by CMCC or by the other partner of this project, but it is developed by Vito and by other partner. And you can then, if you need to have specific support on the use of this tool, or if you have a remark on this app, here on the website you have the contact point and or other general information. Okay, now start to the talk. First of all, a general introduction of the problem. As you know, is ongoing a general increasing of the global temperature, and then this is expected to affect the frequency and the intensity of the heat extreme. That is expected in general to increase in frequency and increase in intensity. This means also consequential impact on urban health, ecosystem, and socioeconomic system. There is different studies working on the evaluation of the frequency and severity of the expected temperature extreme. That is a fundamental knowledge for the climate adaptation evaluation, and then for the definition of measures and strategies at the local level, but also at a national and international level. As told before, the indicators that you are available on this app concern the heat wave. The heat wave is related to the climate condition. Then an heat wave is considered, generally considered in the climate community, like such as a prolonged period of extremely high temperature for a particular region. But there are many different definitions of heat wave because more are related to only to the climate condition, but also other try to take into account other effects, including, I don't know, temperature, not only temperature, but also humidity, wind, and other. And then there are different definitions. In this app are proposed three different definitions. One perhaps more related to the climate condition, while the other two are more related to the impact. In fact, they are defined, one in the European project, Euroheat, and another one is used. Another definition is based on the national definition. From the climatological point of view, it is very, very used, the definition of the heat wave defined by the TCCDI. And the heat wave can be considered as the occurrence of at least 6 sequential days with maximum daily temperature above the corresponding daily threshold value on the 90th percentile, if you want to have a reference. In the tool that we are going to describe, this evaluation of the intensity of a number of heat waves in the future is evaluated using the regional climate model. Regional climate model are the downscaling of the global climate general circulation model. Why we use this kind of models? Because these models have a horizontal resolution higher with respect to the GCM, and then they are more suitable for the evaluation at local level of this kind of extreme. And there are different studies showing that this kind of data can be used as input for impact assessment studies, because the higher resolution permits to evaluate with more detail the local features of the climate, and then of the, especially of the extreme. Okay, I didn't mention that the regional climate model that are used in this tool are the ones available in the framework of the EuroCordex program. The Cordex program in general is a program working on the development of the regional climate model. Over Europe, we have a large number of different model configuration for the different RCM that are available in the scientific community, and this is very important because this means that the evaluation of the indicators is based on an ensemble mean with about 18 for the RCP 4.5 and RCP 8.5 different models. Then we have a quadri-label ensemble mean, but also a good evaluation of the uncertainty of the spread of the different models with respect to the ensemble. And this is quite important for the risk assessment, because there are areas in which this spread is quite large, and this means that there is some uncertainties among the model in the evaluation of these indicators. But if you have if you don't have a large spread, the spread is quite small, this means that there is a good agreement among the different models, and this is quite important also for the users. Okay, my suggestion now is to go on this link. I shared on the chat the link, and try to use the app. It's very easy. It's very well done, this app, and then you can evaluate. You can try to evaluate the number. Specifically today, we try to evaluate the number of heat wave days for European countries using a different climate projection. And this tool is available in the framework of the Copernicus Climate Change Service. In particular, the Copernicus application will concern the climate projection of the number of heat wave days for European countries. And this is specifically devoted at calculating the number of heat waves expected in Europe, not only on the historical period, the 1976-2005, but also for the two different projected 30-year period. The 30-year period is a typical period considered for climate application. We need at least 30 years in order to define correctly the climatology of a certain period, especially if you are interested to look at the extreme. They are considered the 2031-2060 period, and the long time range 2017-2100. Are also considered two different IPCC concentration scenarios, the RCP 4.5 and RCP 8.5. The RCP 8.5 is also named business as usual, because this means that the concentration of the anthropogenic gas increase without application of mitigation policies, while the RCP 4.5 describe a future in which near the 2050 are applied mitigation strategies, and then this concentration is less than the other scenario, the RCP at 8.5. Then two different hypotheses for the future. If you look at the app, you can select in the drop menu the definition. Are three different definitions, as told before. The first one is the definition adopted by the paper of Jacob et al. In 2014, and this was used to present to evaluate extreme using this very huge, important, and very fundamental data set in Europe for the climate projection, the Eurocordex data. If you use this definition, the heat wave is represented as a period of at least 3 consecutive days on which the daily maximum temperature exceeds the 99th percentile of the daily maximum temperature of the period from May to September in the control period, 1971-2000. There is also the possibility to have a second definition, as told before, more related to the impact. This definition comes from the project Euroheat. There are reference for the definition of this indicator in the two papers reported in the slide. In this case, the heat wave depends from the maximum apparent temperature and the minimum temperature exceeded defined threshold for at least 2 days over the summer period. The apparent temperature, including also the humidity, is considered a measure of the relative discomfort due to the combined effect of heat, but also high humidity. And this apparent temperature is developed on the basis of physiological studies. Then, as told before, is more related with respect to the first definition to the impact, to the stress. And then finally we have the third opportunity that can be selected for the definition. We have the national definition. 8 different member states and 1 former member of the European Union has provided their own heat wave definition. In the case of Italy, for example, the indicator is the same, but the threshold are defined at a local level. Then the threshold depends from the local context. My suggestion is to look at the documentation in order to have more detail, but also to look at the paper in which the definition of this indicator is reported in detail. After that, you have selected the definition. You can use the zoom button to select the geographical area. It's not possible to define the area using the drop menu, but you have to use the zoom in button. There is a different possibility. For some countries, it's possible to look at heat wave at NUTS 1 level, and then you can have your result over all the country. But there is also the opportunity for Belgium, Italy, and Hungary and Lithuania to have an additional detail. If you are interested to have this additional detail, you use the zoom in over these countries, and then you will be able to select also more resoluted area. As you can see here, for example, for Italy, if you use zoom in, you can select the NUTS 2 and the NUTS 3. NUTS2 area. Also, in this case, you can use the documentation to have more detail. Now, after this theoretical description, I will give you some examples. Okay, some information about the input and the output. This is very, very important because the data set is provided, is named hot and cold spell for Europe derived from climate projection. Also, if this happens, we only take a look to the hot spell. And the input variable is obtained by the bias adjusted 2-meter air temperature. This is very important because it is thanks to the application of the bias correction to the output of the Eurocordex data that is possible to have as output the absolute value. If is not applied the bias correction, you can only evaluate the anomaly of the feature with respect to the reference period. Then, if it is not applied the bias correction, you can only look at the anomaly of the intensity and frequency of the heat wave in the future with respect to the reference period. Thanks to application of the bias correction means that the systematic error of the model output is removed in some way, is removed, we can evaluate the absolute value. Okay, then thanks to this, you have in the output variables the number of heat wave days in the absolute values. Is also possible using the drop menu to select the period and the scenarios. Okay, here there are more general information about the input and the output. The Eurocordex data are provided on a grid data set, cover all the European area, and only we have a question during the first meeting of this afternoon concerning the possibility to use this app out of Europe. Currently, the app only uses the Eurocordex data and then the data available over Europe region. The data used in the app are the Eurocordex at 0.1 degree of resolution. This is about 12 kilometers. This is the highest resolution available for the using Eurocordex data. I won't say that it is a very reliable data set. There are many papers and scientific publications using this data set over Europe. Then for impact, for adaptation and for risk assessment, this is the best climate data set that we have currently. Here there is a temporal coverage and the data formatted in NetCDF. NetCDF is a binary format largely used in the climate community. It's not easy to use this kind of a format, but unfortunately, this is the only way that we have to use a very huge information. Okay, here is a very briefly described the script that is used for the script that is used for the elaboration of the input data. Okay, you select the area, and then you select the area, you select the definition, and then happens that starts the computation of the daily temperature time series, then the computation of the daily apparent temperature time series, the computation of the heat wave days, the climate average over the 30-year period that you have selected, and then is calculated the ensemble average and the standard deviation. As I told you before, then what you have in the picture, in the maps, is the ensemble mean and the standard deviation, the uncertainty. After that, the data are regridded and then reported on the regular latitude longitude grid. About the output, there are different options that can be selected. You can have a .png. You can download the .png. You can have a one-line chart of the time series of the number of heat wave days using the selected region. But you can also download the NetCDF. This can be very important if you are interested to use this data for further application. Okay, it depends from your requirement. If you want to stop and then look at the time series to have a picture, or if you want to continue your analysis and then you use the NetCDF to start other evaluations. Here there is an example of application. Okay, here you have the definition. Here you have the area. Okay. Sorry. And here you have the different period that you can select. Here you have the near future, means the period 2031-2060, and the IPCC scenario that you have selected. Then here there is the map. Of course, you can have a better picture. Here you have another selection for the far future using the R.P 8.5 and the far future period. Okay, and when you have selected, for example, Italy in this case, you can look at this kind of output. Here you have the number of the trend of the number of heat wave along all the period considered by this app, then from 1976 up to 2085. You have the two different scenarios, the RCP 4.5 in green and the RCP 8.5 in the light purple. And here the medium line is the ensemble mean, while the upper limit curve and the lower limit curve is the spread. For example, you can see that for RCP 8.5, the spread is higher with respect to the spread for RCP 4.5. Here you have the absolute value of the number of heat wave. Here you have the picture for the selected period, and here you can look at the absolute value of the expected heat wave considering the different definitions that are available. And okay. It's very important to take into account the correct definition of the definition of the uncertainty, because there are different definitions. People use the minimum and the maximum model of value of the different models building ensemble, or the 99th percentile and the 10th percentile, or the first percentile, the 99th percentile. While in this case is used a method based on the mean standard deviation and the number of the model of the ensemble. Okay. Here there are other selections. I think that now you can start to use the tool to give me feedback using the chat if you want. And here, briefly, I'm showing a different example. I didn't decide to use the platform in real time, because sometimes if there are many people working on the app, the time for the calculation are longer. But also depending, of course, on the area that you are selecting, because if you select a very big country, this you need to wait some minutes to have the output. And okay, here you have, for example, the far future using the definition of the heat wave following the paper of Jacob et al. In 2014 for the RCP 8.5. Okay, and this is a representation of what I told you before. You have the upper limit is the mean plus the standard deviation, then you have the mean, you have the mean less the standard deviation for RCP 8.5, and here the same values for the RCP 4.5. And as you can see, there is a quite large difference depending on the scenario that you have selected. If you are interested to have a multi-scenario analysis, you have to consider all the differences that are here reported. Okay, some word about the national definition if you are interested to look additional detail, additional geographical detail. Okay, in this case you have to use the zoom in bottom, and to press on the zoom in the bottom and try to go on the area of interest. In this case, for example, is the zoom is and I have selected the Molise area, is a region in Italy, and then if you select this region, you will find, if you have selected in the definition the national definition, you will find that the number of heat wave, the trend of the number of heat wave expected for this region. Here the trend, here the map of the number of heat wave for the different time period and scenario. In this case, as I told before, the threshold is based on the local context. And here you have the different maps that you can have. Okay. 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 I have also some description about the script, but I think that is not very interesting for the scope of this tutorial. Then my suggestion is try to use the app, and if you have questions, if you for me and my colleague, I will be happy to reply. Thank you for your attention. Okay, allora, first of all, I'm looking at the chat. Okay, okay, as I told you before, the application has been developed by Vito, and in collaboration also with other subcontracts, and many information on these are reported on the Copernicus web page. Web page, okay, and I received also another nice question about the historical period. We consider in the climate application the end of the historical period in 2005. Yes, this is correct. We have an upload, of course, but for the moment, the different IPCC scenario start from 2005. Okay, the resolution of the map seems to be very low. The resolution is related to the resolution of the Eurocordex data, that is 12 kilometers. These data are currently used also for analysis at local level, also because thanks to the Eurocordex, you not only have a lot of different models evaluating the same hazard, but you have also the spread. But I don't think that this means that you can also only use this data for national analysis. There are many studies using the Eurocordex data at 12 kilometers for local analysis. Of course, I mean, at the moment, this is the best data set that we have in Europe for climate projection. And I mean, the best in sense of resolution. We are working the framework also of the flagship of Cordex to the definition of new climate data set at about 3 kilometers of resolution. But for the moment, these data are not available on the long-term period. Then this data set is the best that we have. But if you, I mean, I have my personal experience is that if you compare on the historical period the result of Eurocordex and with the result of the observation, the skill that you have is quite good. 12 kilometers of resolution, I think that is a good resolution also for local application. If local means, of course, not I mean. Big city, of course, in one point is quite different. Also, if they can be used if you, for example, you perform a bias correction using a local observation. I think that I don't know if I have replied to the question, but if you download the net CDF and then you download the data, then you can try to have a more resoluted picture at local level. But the data are good enough to perform also local adaptation analysis. For the urban area, I won't say that we need to apply really bias correction, because this kind of climate model don't consider the effect of the building area in the effect of the building and then perhaps there is an underestimation of the urban heat island, for example, and then the bias correction is can be an option to correct this data, but at the moment this is the only data set that we have, and it can be used carefully if you consider all these limitations. We don't have time for an additional session, but if you want, you can make your question in the chat and try to use the app. Okay, I see that there aren't other questions. Then we can stop here this section. Thank you everybody for your participation. I hope that it was useful for your work, and please don't hesitate to contact us for other information. Thank you. Bye bye.